Math 3, Unit 2, Semester Final Review, Part 2. Okay, so today we're talking about systems of inequalities and graphing. Remember that when you are doing a system of inequalities, your answer is where the two graphs overlap, okay? And they'll say, like, name 2 points, so you're going to just pick 2 points. There's a lot of points, but you're just going to pick 2 points where the two graphs overlap. Okay, so we're going to start here with f of x, and we're going to graph it. So the first thing is that you need to know what type of graph that is. Very good. So we know that f of x is an absolute value graph. I'm just going to write here absolute value. Okay, when I am graphing f of x, my absolute value, what things do we need to know? We need to know our vertex, and this, actually that's not, just kidding, it is absolute value. What is my vertex? -2, -1, and then we also need to know the slope, okay, which we can say is m or a, whichever way you like it. I'm going to put m, you can put a. And what is my slope?
5/3.
5/3 is correct. Now, another thing we need to remember is these inequalities, okay? So, this inequality, is it solid or dotted?
Dotted.
Very good. How do you know that it is dotted?
It's not equal.
Very good. This line? Solid, okay? And in fact, I'm going to write here dotted, so that hopefully I remember that I'm going to make that a dotted line. Okay, so let's go graph that. So I'm going to go left 2, down 1, there's my vertex. Now because this is positive slope, that means I'm going to end up going up. So up 1, 2, 3, 4, 5, and right 1, 2, 3. And then remember we're going up 5 and then left 1, 2, 3. Now, am I going to draw straight lines for this? Yes, but I'm going to make sure that they are dotted. If you forgot, just make sure you go back and make it look dotted or dashed, however you want to say that. Okay. Now, there's one more thing we have to do on that. And does anybody remember what it is? Shading. Very good, shading. So this says less than. Where do you think I'm going to shade for less than? Very good. Underneath. Okay, so the shading will be on the outside. If it was greater than, it'd be shaded on the inside here. Okay? Okay, questions before I move on to the next graph? We're good? Okay, so the next graph, g of x, what type of graph is that going to be? Very good. I'm just going to write line, but linear is actually better. Okay. And in order to graph that, it's really just a starting point. We can put it as a vertex. I'm going to put point. You can put v, whatever you want to do. And what is that point going to be? 1, 2. And then the other thing we need is our slope, which is? Good, -1/2. Okay, and again, this line is going to be solid. Very good. Okay, so we start by going to 1, 2. So right 1, up 2, make a point. And from there, I'm going down 1, right 2. I could have also gone up 1 and left 2. And then we're going to draw a solid line here. Also notice I like to do different colors on here so I can see the different graphs a little better. It's up to you. You don't have to do it that way, but I find it helpful. And this one says that it's a what type of graph? Greater than. So when we have greater than, we're going to shade up or above the line. Now, do you see where the shading overlaps? So each graph we have to shade. And then the answer is actually the overlapping portions. Do you guys see where they are? So it's actually at 2 different places here. So it's overlapping in this area right here. And then it's also overlapping in this top part right here. Now, on your final, when you have multiple choice answers, they're only going to show you the overlapping portions. Okay, that will be the only part that's shaded. Okay, so now we need to name 2 points. You can name any points that you want to. It's usually a good idea to also check the points that you choose, and they have to make true statements for both of the equations. Anybody have an option for one of the points? And if we're going to check one of the points. Okay? 4, 2. So if you go right 1, 2, 3, 4, and up 1, 2, that does look like it's in the overlapping shaded area. So that's a great option, 4, 2. Another one that I like to work with is when we have 0, because 0 makes things cancel out, right? And so do you guys see any that would give me 0 as a part of the point? So if you count across on the x-axis, let's see here, 1, 2, 3, 4, 5. We could do 6, maybe 7 just to be safe that I graph right. So 7, 0. Or no, it's not 7, 0. Yeah, 7, 0. Okay, so we can check either one of these. Which one do you guys want to use? 7, 0. We wouldn't want to use, did you say 1, 2? Oh, so either one, it's up to you. I'm going to use 7, 0 just because I think it may be easier. Okay, so we plug 7, 0 into our equation. So I'm starting with f of x, okay, is less than 5 over 3 absolute value x plus 2 minus 1. So remember f of x actually represents y. I also recommend that you label these as x and y, okay, to make sure you're putting them in the right spots. So that means for this equation, I'd have 0 is less than 5/3 absolute value of, thank you, 7 plus 2 minus 1. What is 7 plus 2? 9. Absolute value is 9. And then we multiply, and we end up getting 15 minus 1, right? Which is 14. Is 0 less than 14? I just kind of did this in my head, but 3 reduces with 9 and becomes 3. And then 5 times 3 is 15, and 15 minus 1 gives me 14. Okay, so that one's true. It works out. And then you have to check the other equation. So that one is g of x is greater than or equal to negative 1/2 absolute value x minus 1 plus 2. So we're using the same ordered pair, 7, 0. Plugging in for g of x. Again, g of x is like our y. So we have 0 is greater than or equal to negative 1/2 times 7 minus 1 plus 2. 7 minus 1 is 6. 6 times negative 1/2 is negative 3, right? Plus 2 makes negative 1. Is 0 greater than or equal to negative 1? Yes. So it also checks out. So we know this is a good point. Also, if they are just asking you, is a point a solution to the systems of inequalities, you could just take the points that they have as the options and plug them in and see which one makes true statements for both equations. Okay, do we have questions on that example? Yes?
For the first point,
Uh-huh.
how would you check that in? Would you check the 4 or 2 or what?
Yeah, same thing. So this is your x and y. So you end up plugging in 2 for y and 4 for x. So it's the same thing, you just have different numbers. Okay? Yes. Yes. Okay. All right, next equation. So we have another system. Okay, our first one we have here is f of x is greater than 1. Okay? What type of graph will that be? Good. It's going to be a line or linear. Is it going to be solid or dotted? Very good. And again, how do you know? Guys, focus, please. Okay. It doesn't have the equal sign. Okay. Where do I go to graph this first equation? Where do we go when it just has a number? Good. Up 1. Okay. and we're going to make a dotted line here at 1. Okay, where will I shade? Very good, going up because it says greater than. Okay, next we have our g of x equation. I'm going to rewrite this one. I don't like how it's written. Do we know what type of graph that is? Parabola or a quadratic. Because it's exponential when your x is in the exponent, but when we just have a 2 there, that's your parabola or quadratic. Okay, so I'm going to put my x squared part first. So how would I end up writing this equation? Good, negative x squared and then plus 4. It's easier for me when I look at this to see what my vertex is. Okay, is this one going to be solid or dotted? Solid, and we know that because there is. Very good. Okay, now what's my vertex on here? So always look at like the squared term. And is there parentheses or anything being added with the squared term where it's in parentheses? No, so the x part is 0, and then the y part is always the part at the end. Okay, so it's 0, 4. So when we're graphing this one, we're going to go 0 and then up 4. And this parabola, is it going up or down? Down, and what's my a value? 1. So it's like negative 1 over 1. So from here, I'm going to go down 1, right 1 in both directions. Now, we're just kind of, we're not making it perfect, okay? And then this one says less than. So which way will I shade for less than on this parabola? Down, which will end up being inside the parabola because the parabola is going down, so the less than values are inside here. Okay, do we see the portion that's overlapping? Yeah, it's this part right in here. Now we know it's not perfect, but could you pick 2 points that you know are for sure in the overlapping portion? What do you think, Anthony? Good, 0, 2, and what would be another one? 0, 3. I would pick those because I know those are for sure exactly. Okay? Yes, so let's just check one of them. Okay? But this one's actually going to be a little bit easier because there's not as much going on in the equation. So again, I would label these as x and y to make sure I'm putting them into the correct spots. And so we have f of x is greater than 1, which really means y is greater than 1. Well, what's my y value? 2. Is 2 greater than 1? Yes, that one checks out. We're good. Okay, so my g of x equation is negative x squared plus 4, and that's supposed to be less than or equal to. And again, g of x really represents y, and then the x is right there, right? And so we're going to write 2 is less than or equal to negative 0 squared plus 4. Well, negative 0 squared is just 0, and 0 plus 4 is 4. Is 2 less than or equal to 4? Yes. So that checks out, so we know for sure that point does work. Okay? Any questions? We're good? Okay. Moving on to the next page. Solving quadratic equations. So up here at the top, they're just going through how to solve the different types of quadratic functions. Okay, so you can use square roots, and this is normally when you have like a squared term in parentheses like this. Like so down here at the first example, you want to get the square by itself, and then you're able to take the square root of both sides. But whenever you take the square root, make sure you use plus or minus. When you're factoring, make sure that you always set equal to 0 before you factor. And then you set each factor equal to 0 once you do that. And then same thing with the quadratic formula. Make sure you set it equal to 0 before using your quadratic formula. Okay, so we just have 3 examples here we're going to do at the bottom. So starting here with the first one, we kind of already talked about this, but we noticed that we have a parenthesis that's being squared. So the easiest thing to do is get that square by itself. Okay? No cell phones during notes. All right, so what am I going to do first? Very good. Add 5 to both sides. So this cancels. We get 1/2 parenthesis x minus 3 squared equals 14. Is the square by itself? No. What do I do next? Very good. Multiplying by 2 is correct. So that cancels that out. We have x minus 3 squared equals 28. Okay, now how do I get rid of the square? Very good. So we take the square root of both sides, which means I get x minus 3 equals, and because I made a square root, it's going to be plus or minus. Okay? Now, if this was the square root of 25, I know the answer would be 5. But 28 is not a perfect square. So we need to break it down and simplify if we can, though. So what two numbers multiply to be 28? Okay? Either way you do that. And then 4 would be 2 and 2. Or if you did 2 and 14, then 14 would be 7 and 2. Either way, you end up with a pair of 2's and a 7 left over. So how do I write that? 2 root 7. So your pair gets to be brought to the front, and then whatever is left in the root stays under the root. Again, cell phones should not be being used at this time. Okay, our last thing to do is what? Get x by itself. So there's a minus 3 with it right now. So what do I do? Okay, now, can you add 3 to 2 root 7? No. So we just write this as x equals 3 plus or minus 2 root 7. Are there any questions on that problem? Okay. Next one. Can I use this as like the two factors and go x equals 8 and 3x minus 2 equals 8? Can you ever do anything like that? No. We always, when we do something like this, it's that they are set equal to 0. And since this is not set equal to 0, we have to multiply it all out and set it equal to 0. Okay? So we're going to start by distributing the x. So x times 3x makes, good. X times negative 2 is negative 2x equals 8. And then what would I do? Subtract 8 because we want it set equal to 0. Very good. So 3x squared minus 2x minus 8 equals 0. Who remembers how we would end up factoring this? Good. Okay, so 3 times 8, or 3 times negative 8 makes negative 24. And then we have negative 2. So what numbers will multiply to be negative 24 and add to be negative 2? Good. Negative 6 and positive 4. So do you remember what I do to write the equation now? Good. 3x squared minus 6x plus 4x. Good. Minus 8 equals 0. And then because I have 4 terms, we factor by grouping. Okay, so what can I take out of my first group? 3x. And I'm left with x minus 2. What can I take out of my second group? A positive 4. And I'm left with x minus 2. So what does that end up factoring to be? Okay, 3x plus 4 and x minus 2. And remember that there's really only one x minus 2 because the x minus 2 became the GCF that we took out and you're left with whatever is in front. So this is one parenthesis and the leftover parts in front are the other parenthesis. When you set those equal to 0, what do you get? So if you're ever not sure, just set it equal to 0. Okay, so you'd have to subtract 4 to both sides. 3x equals negative 4, and then you divide by 3. So x equals negative 4/3. On this side, we add 2 to both sides, and we get x equals 2. So the answer for that is negative 4/3 and 2. Any questions? Okay, last problem. So on this one, if you were to go over by 2, you get 17, or sorry, not 17, 14. And is there anything that multiplies to be 14 and adds to be negative 3? No. So what method are we going to have to use? Quadratic formula. Okay? And so with the quadratic formula, so I'm just going to go ahead and cross that out here. We know that A is 2, B is negative 3, and C is 7. Make sure, though, that it is set equal to 0. If it's not set equal to 0, you have to move everything around until it is. Okay, so quadratic formula. We get x equals negative b, which would be positive 3, plus or minus the square root of negative 3 squared minus 4 times a, which is 2, times c, which is 7, all over 2 times 2. I like to save myself a little bit of time, so I would go ahead and square negative 3. So negative 3 squared is 9. And then we have negative 4 times 2, which is negative 8. And negative 8 times 7 is negative 56. So we end up getting x equals 3 plus or minus the square root. And what's 9 minus 56? Negative 47. All over 2 times 2, which was 4. Okay, what do you do when you have a negative under the root? We bring the negative out and it becomes an negative. Numbers under roots are imaginary. So can I break 47 down? No. So we just get 3 plus or minus I root 47 all over 4. What's the question? You got it? Okay. Does anybody need anything re-explained?